Hopefully you can eliminate two of these so you can try to guess what the other ones are, because you'll end up with a disk order that's unknown. That's the easiest one to solve in most cases, because all you have to do is make sure that the guy who knows that the array is dead wrote a number on the box before each drive is removed. That's the easiest one to deal with. So if you can convince people to do that before they ship them to you, you might be able to figure something out without having to spend a lot of extra time. Then you've got your variations and your slice sizes. Now, sometimes that configuration is stored on the disk themselves, and maybe you can't read that, or you can't get into the card, or you can't see the card, so you don't know what that is, so you're going to have to guess. And then you've got the arrangement. The arrangement is usually not something you can specify or select. It's usually something that the manufacturer chose. There's basically 5 or 6 different types of arrangements. And so those arrangements, it's important if you know which discrete controller it is, you can look them up. And then you have fragmentation. Fragmentation is going to impact you in this demo that I'm going to do altogether. But fragmentation, as most of you know, you've just got to deal with fragmentation. So what you're going to do is you're going to check multiple pictures. You're going to have some that are corrupt no matter what because of the way that the layout is. So when you click on them, you're not going to get anything. But as you click through a dozen or 20 of them, you'll figure out which ones you can view and which ones make sense, and just ignore the others that are bad that you can't do. So they start to look like jigsaw puzzles. So we have something kind of similar to this from that standpoint. We actually have the same thing with RAID 0. Same basic slice sizes that you've got to deal with. But there's some extra things that you can do to try to figure out the steps. So here's kind of my extra slide. This is the bonus stuff. You don't have to do this to do it. Once you've actually done enough views of the drives, you can figure this out by sight. But here's one thing you can do. Anybody ever done a manual carve of JPEG files? How many people done that? Yeah. Okay, so for the people that haven't, it sounds like some big mystery all these forensics guys are doing, or manual carving, whatever. All it means is I copied the hex crap out of the drive. That's all it means. So what ends up happening, let's just say I go and I look up the JPEG standard. In the JPEG standard, you got FFDA-FF is basically what your file is going to start with. So you're going to end up with a JPEG header. It's always going to begin with FFDA-FF, and it's going to end with FFD9. So you'll be able to go from beginning to end and cut something out. So if you go into a hex editor and you just look at the content, you do a search for FFD8FF. So when you actually get to that spot, the first thing you want to do to find out is whether or not you've got a false positive. Is this a false positive? No. Because the easiest thing you can tell right off the bat is you got some EXIF information. So there's data that's actually stored in the picture about the picture. So you'll get things like the camera, dates and times, and stuff like that. That stuff is very valuable to help you figure out in the RAID array how to reassemble it. Because this is probably, the beginning of the picture is probably going to be a JPEG. So if I extract this data, even if I can't view the actual file, the JPEG is typically going to be smaller than my slice size. So I can see the thumbnail itself. So if I extract it and I just save it to a directory, the picture itself won't open. The picture is complete and utter crap. You can't see anything. But I'm just going to use Explorer by highlighting over the picture, and it'll tell me what size that the dimensions are supposed to be. But you can see it says it's 8K. I mean, that's a pretty small thing, so that's not the real picture. But you take these numbers, and you can go to a website, and it'll calculate for you what the actual size is supposed to be. You plug them in, and you come down here to what your JPEG process is going to be, and you can figure out, I mean, most photographers are going to save it somewhere in the 100% range most of the time. So you're going to end up with like a 2 meg file. So then you can actually take the files as you extract them, and you go through the process. You can kind of break it down. You could say, look, it's supposed to be a 2 meg file. So what is my slice size? And so you just start dividing until you actually look like you're starting to get a slice size that's contiguous. And what that slice size that's contiguous is most of the time the actual correct slice size. Even though, in this particular case, we may have a rotation in order, or we may have slices that are out of order, so I have drives out of order. But I can still tell that this is probably going to be a 64K slice size. So you have other things to look at, which are, do these other slices belong to the same picture? So this is where you're going to resolve 2 X's at one time. If the picture has slices that look weird and don't fit in the picture, then you've got an order problem also. So not only do you have the slice size problem, you've got an order problem, and either the arrangement of the logical component of the drive is going to be wrong, or the order of the physical drives that you have is wrong. So I'll kind of give you a picture of that. So if you look at this, there's basically 4 major ways that the data is arranged on RAID arrays. And this is typically Linux terminology. Windows has the same kind of thing, but they call it stupid stuff like forward and backwards and dynamic, and they just make other crap up, but it's pretty much the same thing. So you're looking at these orders. So I'm going to focus on the first two because the first two are the most common. So you end up with what's called the left asynchronous. So you basically can tell where your slices are. So you'll have like a strip that's good, a strip that's bad, and so on as it rotates through. And you'll have a second set that'll actually be different orders in the numbers. And so you'll actually have content. The picture will actually look fairly similar to this. You'll actually get a picture that if once you've got the order of the drives correct, that the content that's in the picture rotates through in the same order and looks fairly similar. So as you look through these slices, then you start to go, hey, which order is this one? I can pick them. So this is the tool that I'm just going to use basically to show this. So I can actually load my 3 drives up. This is going to be the order of it. And so this is one of the arrangements. This is one of the other arrangements that I can deal with. So you can start to see and do a comparison. And then once you actually put them back together, you'll actually get the complete picture itself. So what are the steps that I would normally do to do this? I'm going to repair the bad drives. I'm not going to waste a lot of time. That's like the first thing that I see so many people do. Like, oh, we got 7 drives in for recovery. They image the first 6. Like, well, what about the bad drive? Because if you don't get the bad drive back, or the first 5, if you don't get the bad drive back, you're not going to get the one that you actually need. It won't matter how much work you do. Before that, it's going to be all wasted time. So I work on the bad drive first, and sometimes you just have to start doing an image or something to test to figure out which one's the bad one. But most of the time you know pretty quickly. Then you can actually deal with imaging the good ones and stepping through the process, test the data, and then once you finally actually have them assembled, you can go back. Now, on the thing that I was talking about, let's try to do something free. There is a Perl script out there that somebody wrote to try to help out with this, and it's been used several times, so it's functional and works. So if you just do a search for Mike Hardy, you'll actually find that there's a Perl script that's already written to kind of step through them, and you modify it according to your array. So you would still have to kind of know something about it. All right? So let's go through the process of what we're going to deal with our goals. So our goal was let's use something that's less than $100 and try to rebuild. Now, there's some tools that will rebuild RAID 0 but won't rebuild RAID 5. So make sure that if you buy something that you know what you're doing, which one you're going to buy. So I have 2 primary choices that I would use. RAID Reconstructor from runtime.org is $99, and then there's RStudios from RTools. And that's actually a great buy because RStudio is $79 or something for their standard edition, and it does like all the file systems except for XFS and ZFS, but it does the rest of them. So you can typically do everything all at once, including Mac OS or whatever. RAID Reconstructor, I'm not going to show at the moment because RAID Reconstructor, it guesses, and if it's right, it'll tell you. If it's wrong, what it will normally do is tell you what its entropy is. And the trick with RAID Reconstructor is if there's an OS equals 4, if you see OS equals 4, those are the ones to try. So there'll be a column that'll say OS equals 4, and you'll have 4 or 5 drives in the list out of 70-something drives. It'll tell you which ones are the ones with the highest entropy. Those are the ones to test. But I'm going to show RStudios. So that's what my demo is going to be on. Question? Okay. All right, so hopefully this will be the right size for me to see. Okay, so I don't so much care about the actual product itself. My whole goal is to be able to see what's manually going on, to actually know what's going on. So hopefully this is a big enough window for me to see all the buttons. All right, so the first thing I'm going to do is I'm going to go to Drives, and I'm going to open image file. So I've made DD image files. I've made a pair of them. So this is a RAID array that had 3. Now, if this is unknown, basically you take your defaults and then you kind of work your way back from there. So ultimately what I'm going to try to do is I'm going to take these DD image files of 2 of the drives that I've repaired, and I'm going to try to see what the content is from there. So since I have 2 out of a RAID array that's supposed to have 3 drives, I have to make a fake one so that the parity is calculated. So I'm going to highlight these and add it. Now the first thing, which drive is number 1? So you see right away that the software actually identifies in these 2 image files that I actually have a sector that actually identifies itself as NTFS. So I actually have, now this was a hardware RAID, and I broke it basically to do this demo and made these image files of that particular one. But I have two image files here. I'm missing the missing drive, but I know which one's number 1. So what I'm going to do is I'm going to go and create me. They call it virtual block RAID. So this is going to be my RAID 5. So I make kind of a fake set here. Then I'm going to add each one of my drives to this. So I right-click, and you'll actually see your drives and your partitions. The drives are the one that's mattered because the partition is going to be at an offset, and you don't want to use the offset. So I'm going to add the 2 drives I have. Now, right now, I cannot see my boxes, so I'm going to add my missing disk. Now, if you have to